are going to be looking at some integration here. And level 1 is going to be basic integration, and level 2 is going to be using that U substitution. But we're going to all go over that. Everyone's going to go over that U substitution together. So I have a worked out example and also some integrals that you have to memorize. I did make a note here. You must include the absolute values around. If you're integrating 1 over x, you have to do the natural log of the absolute value of x. Just keep that in mind. So our worked out example, remember U substitution is what we use when you're like, okay, I cannot easily integrate that. There are 2 separate things going on here that are the part of, if you were differentiating, you would use product rule or you would use quotient rule. And U substitution is like essentially what is like kind of undoing that. So or product or quotient rule are kind of like undoing U substitution. So when I look at this, I'll leave that example here for you guys to check out, and we're going to go over this mixed problem together. When I look at U substitution, the most important thing is to kind of identify like what should U be. Now, because this is 3 cosine of 2x plus 4, that's a little bit larger of an expression than sine of 2x. So I'm actually going to make my U 3 cosine of 2x plus 4. Reason behind that is because when I differentiate that 4 is going to go away. And I also know that the derivative of cosine is sine. It's a negative sign, so this is going to look a little bit nicer. So when I take that derivative, I get that this is going to be negative 3 sine of 2x times 2. And remember, the derivative of 4 is nothing, so I'm going to say du equals negative 6 sine of 2x dx. Now remember, the whole idea is that we're replacing as much as we can. We don't have negative 6 sine of 2x dx. We have sine of 2x dx. So I'm going to divide by negative 6. Or I'm going to do a negative 1/6. Same thing, right? So we know that that is equivalent to sine of 2x dx. When I substitute, we're going to have, this is going to be, make sure we say x equals 0 and x equals pi over 4, because now we are substituting in terms of u. So you can go ahead and sub a 0 and solve for that and put those limits in terms of u. We'll chat about that in a second. But for now, make sure that you're noting that these limits are in terms of x, not in terms of u. Now I know that u is 3 cosine, that whole denominator. So that's going to be over u. And then I also know that this sine of 2x dx is equivalent to negative 1/6 du. So I'm actually going to do a negative 1. I'm going to put that 6 here, and then that's du. I'm going to change these limits to be in terms of u because that's just going to be easier for me in general to do. So let's get this done. We know that if I plug in pi over 4, 3 cosine of 2 times pi over 4 is pi over 2, plus 4 cosine of pi over 2 is 0, so this is going to be a 4, and this is in terms of u. And then if I substitute 0, we have 3 cosine of 0 plus 4. We know that that's 1. 3 plus 4 is 7. So now those limits are in terms. We're going to say negative 1/6 u du. And then I'm actually going to say this is negative. Since my higher value is in the bottom integral, we're going to say this is 4 to 7. And I'm going to pull that negative out from that 1/6. So it's going to be a positive 1/6 u du. Again, some more manipulation. Let's pull that 1/6 out. So that's going to be 1/6 times the integral from 4 to 7, 1/u du. Now we're in a place where we're like, okay, this is actually pretty manageable. We know that the integral, we can go back and look at our rules. The integral of 1/x is the natural log, and we have to use those absolute value signs. So we have 1/6 times the natural log of u. And then we are evaluating this from 7 to 4. Put that in parentheses. So At this point, we are going to come down here and start substituting that in. Remember, since we put this in u, we don't have to go back and plug in this whole sine of 3 cosine of 2x plus 4. Because we put those boundaries in terms of u, it's going to be a lot easier to work with. So I have 1/6. We have the natural log of 7 minus the natural log of 4. And then a friendly reminder that we can use those log rules to make this 1/6, the natural log of 7/4. And there is our answer. So when we're in level 1, that means that you are like, wow, what you just did was a little bit crazy. Let's kind of go through this a little bit slower. We have, this is no calc, the acceleration of a particle is moving along the x-axis at time equals t given by a sub t equals 6t minus 2. The velocity is 25 when t is 3. And the position is 10 when t is 1. Then the position x sub t equals what? Okay, so we have a few integrations going on here. We remember, if I think through, you remember that it goes, the integral of acceleration is velocity, and the integral of velocity is position. So we are looking for that position, which means we need to integrate 2 times. So the first thing is, let's get this integrated. So the integral of 6t minus 2. We do not have a definite range. We're just looking for that general solution here. We are going to add that. So remember, that becomes t squared. 6 divided by that new exponent is 3. And then you have minus 2t. That new exponent is 1. 2 divided by 1 is still 2. And that's plus c. So I'm going to say v sub t equals. So we have v sub t equals 3t squared minus 2t plus c. I'm given an initial condition. Velocity is 25 when t equals 3. So I can say 25 equals, to solve for c, 3 times 9 minus 2 times 3 is 6. So 27 minus 6. So I know that c equals 4. This one's going to take a little bit of room, huh? Let's get that. So we're going to come back over here and say 3t squared minus 2t plus 4. Now, it didn't ask us to find velocity, it asked us to find position. So I know that x of t, the integral of 3t squared minus 2t plus 4, this is all in terms of t, this equals xt, or position. So then when I start integrating this guy, we say that dt because remember, this is the derivative. So we're integrating that to get rid of that derivative to find that position function. So we have a t, that 2 becomes a 3. Divide 3 by 3, I get 1. We have a t, that t becomes a squared. 2 divided by 2 is 1. We have a plus 4t. And remember, we don't know that constant. But I do know, I was given a little bit more information back in that problem, that the position is 10 when t equals 1. So I can come back over here and say this is t, 10. 1 cubed is 1 minus 1 squared plus 4 plus c. So I get that c equals 6. So I know that this guy right here is supposed to be a positive 6. The equation that matches that would be c. Next one. A particle travels along the x-axis with the velocity given by v sub t equals 6 sine of t over 2. If the particle is at x equals 1 when t equals 0, then the position at t equals pi is what? All right, so again, we're going from velocity to position. So I'm going to say x of t is the integral of 6 sine t over 2 dt. If this were an FRQ, you would need to note that x of t is the integral of v sub t. So they're not just like, where did you pull that x of t from? Making that connection. So let's integrate this guy right here. I know that the integral of sine is negative cosine. The 6 gets pulled out, so this is 6 times, we have negative cosine of t over 2. The integral of 1/2 t is going to be times, or the derivative, remember that chain rule happens here. And then this guy is going to be plus c. Oh, and guys, I just realized I did that wrong. That should have been divided by 1/2. So that's times 2. I apologize there. So then we get that x of t equals negative 12 cosine of t divided by 2 plus c. Then we substitute that initial condition. The particle is at x equals 1 when t equals 0. So we know that this is 1 cosine of 0. So that's negative 12 times 1 plus c. And c is 13. So getting that written out, x of t equals negative 12 cosine of t divided by 2 plus 13. Now when I plug in pi, cosine of pi over 2, ran out of room there, sorry about that. Cosine of pi over 2 is 0, so that all cancels, and I get that that value is going to be 13. And we are good to go. Last one here. A particle moves along the x-axis so that its distance from the origin at a time t is given by 10 minus 4t squared. What is the total distance covered by the particle between 1 and 2? So when I get that written out, we know that we're integrating between 1 and 2. I need to use that actual, this is position, right? So when I integrate, that puts me to position. So the total distance is going to be the area under the velocity curve. I know that velocity is the derivative. So v of t is going to be 10 minus 8t. Absolute value, because total distance, so we don't care about positive or negative signs, 10 minus 8t dt. Coming over to our calculator, we're going to do a math 9. We are going between 1 and 2. That absolute value is found in that math num menu, that like number. And then we're going to say 10 minus 8x dx, and we get 2.5. Now, it is important that you do go ahead and take the derivative and then throw that in your calculator for the integral because of that absolute value sign. Remember that when we're talking about distance, every single piece of the curve we treat as positive. We don't have positive and negative areas. So that is an important thing to keep in mind.